Hi, everybody. My name is Daniel, and it's an honor to be opening Swift and Fika. I hope you had a good day yesterday, and I hope you enjoyed the Fika downstairs, and it's going to be a great day, I think. I know. So I, as was so greatly introduced a second ago, I spend a lot of my time building API for everything. So I started when I was a kid. I bought an iPod back then, and I spent my summer while I was 18 reverse engineering the database, which I'm sure is a very normal thing to do when you're 18 over the summer. But today, even though it says so on the slide, I'm not going to directly talk about the nuts and bolts of designing an API. There's something more important in API design that informs this, and we can find lots and lots of things online, and I'm sure there's going to be talks today on actually how to, arrange your classes and how to have your methods look. But there's something a lot bigger and a lot grander in API design that's really important to think about, and often it gets skipped. But since the interest slide did say API design, I'm just going to give you a very quick, 30-second, here's what I think, some, high-level API design things. So when you're putting together your API, don't try to be too clever. Don't make it too complicated. Boring is best. When in doubt, copy Apple. Because you need to be aware that, especially if you're shipping your API publicly, there's a saying in business, probably, you need to make it easy for your customers to give you money. And if you're shipping an API, you need to make it easy for potential users of your API to use your API. So if you have a ton of complicated things, or you have a ton of dependencies on various this and that, then the bar to entry for your design is much higher, and people will skip you. So if your business depends on having a working, and people using your API, then making it more difficult with dependencies and complicated things can be, detrimental to people, a higher bar of entry. With APIs, boring is good, because, you don't ever see, oh, I've got this new thing, and it's super exciting integrating it in. And, people care about what your thing does, not how to do it. And the thing is that Apple have been doing this for years, and everybody knows Apple's opinions on how an API should look. So that's the way to get the most people. So what we're actually going to talk about today is this, the API boundary. So the API boundary is the boundary between the code behind the API and the code ahead of the API. And it's an odd question, right? So where do you place this boundary? So, well, you place it between the framework code and the client code, right? Easy. But as an API shipper, somebody writing an API, you get to choose where this boundary goes, and it is actually a very, very critical thing. And it has huge ramifications for the use of your API and your code base. Because you need to remember there's always more code than you ship to actually achieve the task that you're shipping in your API. It's very rare that you can just integrate a framework into your project and have everything work. Normally the client has to do something. So when you ship an API, you could choose to have the boundary much closer to the framework, so the majority of the code goes in the client, or you could choose to have it a lot closer to the client, so there's way more code in your framework, but then the client has almost nothing to do. And this is very important because you are shipping that total amount of code. So even though you ship this, you're also shipping the requirement to do this. And the thing about this code is that the client, the app, whatever's using your framework, cares about it more because it's theirs. And every time you make a change to the left of the boundary or on the boundary, you have potentially you're changing all of this. So the smaller that is, perhaps, the less work it is for the client to change. So I'm going to pick on a couple of frameworks that are out there in the wild. Two I use. So the first one is the Spotify metadata framework. And this is for doing Spotify stuff that isn't music playback. It's a public thing. You can get it on GitHub. It's nice. Some of the early commits in mine, but I haven't worked on it in years. You use it to look up artists, albums, playlists, whatnot. And their boundary is very far to the left. So when you integrate the Spotify metadata framework, the client side needs to know about OAuth and token renewal, and it needs to know about session management, and it needs to know the object model of the back-end API that they've chosen to implement. And effectively, the object model they've chosen for their back-end through their framework becomes an implementation detail of the client. On the other hand, Crashlytics is a very common or very popular API and service used for doing crash reporting on iOS apps. And the Crashlytics service has a super deep API boundary. It's right up here. And to integrate it in this side, it's one line of code for most cases. And this has a ton of trade-offs. So there's a lot more work for them, a huge amount more work for them, because they need to write all this code for reporting crash reports. They need to consider, all of the ways that people might use their apps, the threading models of all these apps, how they might choose to do networking. It's a ton of work. But then again, Crashlytics has been bought out twice now. It was independent, then it was owned by Twitter, now it's owned by Google. And as far as I can see, there have been no major changes to their API. They could be emailing your crash reports to an email to fax service and having interns type out the crash reports, as far as we can tell. We have no information about this. And I want to be very clear that both approaches here are super valid. They're completely valid, depending on your internal wants and needs and how you want to do. The left-hand shallow API boundary is great if you don't have a ton of resources to ship something, if you want to get something out nice and quickly and work forward, and if you don't mind that your backend or whatever is a implementation detail of the client. And on the other hand, Crashlytics model is much more effort, much more work, but you have a lot more flexibility. So we're going to go into an opinion here. Personally, when I'm working on my things, I prefer the Crashlytics model more. It's a lot more work, but I think it makes for a better overall experience for the client, because they don't have to care. In the nicest way possible, I don't care how Crashlytics works. I want crash reporting for my app. I want it to work well. They can implement it however they like. It's not really my concern. Of course, there are people who want to know exactly how everything works that's in their code base. Completely fine. And another thing I tend to do is that if everybody using your API has a task that they'll end up doing when integrating it, you may as well put that in as well. If everybody does the same thing. Yeah. This should not have been in. This is a skipped part. Okay, so with that intro done, let's talk about my favorite thing, and that is me. So for my day job, I work with cameras. These things, system cameras. They are, you take pictures with them. So I work with an app that connects to these things and adds features to them, downloads photos from them, adds automation tools. And a lot of the work is reverse engineering, because they don't tend to publish their things publicly. And I also I implement my camera communication stuff in a SDK called Cascable Core, which is very imaginative. And that's used by the main app and by third-party customers. Now, this is a camera. They're not that exciting. And on the surface level, all of the cameras work the same. So light goes in the front here. There's electricity in the middle. And then pictures come out the back, or the side, I suppose. From there, people start to disagree between the camera manufacturers. And this just becomes chaos. So like all of these different manufacturers, some use HTTP, some JSON. That one has invalid JSON quite often. XML, these are binary over here. Like the discovery is different, or no discovery, so you just have to know it's there. Yeah, so few similarities there, but they're mainly very different. And this kind of forces us to have our framework API boundary right up here, because if we expose that chaos to the client, there'd kind of be no point. You'd need a degree in dealing with stupid bullshit to get anywhere. Because this one does return invalid JSON sometimes, like just commas missing and stuff. It's very strange. And the whole point of it is that there's a lot of code here, so the client doesn't have to care. And this is a sample thing. You get a camera from the discovery thing, you connect to it. If the error's fine, you can take a picture. Depending on the manufacturer of camera, that could be involving like 10,000, 15,000 lines of code on the API side. Like, these are very complicated sometimes. So this is very much, you don't worry about camera communication, we will worry about blank. So I promise you API adventures. So let's go on an adventure. So first and foremost, we're shipping an API. So one thing we need to do is get the live view, which is, if you bring up your iPhone camera, you can see what the camera sees before you take the picture. That is live view. Some cameras do it like this, where you send a request, you get one frame back, and then you send another request, and you get another frame back. And it's more efficient than you might think. Like, those requests are only 8 bytes, so you can do 40 frames per second fine. Others do it more simply. Like, you send a request, you just get stuff until you tell it to stop giving you things or to disconnect. Now, what we need to do is to unify this into a common API that works with everything. And it is the same concept, but in the back end, which are these, they're different. So what this forces us to do is stop, look at the client, and then design the API from that way. So rather than, because it's very, very common to, like, okay, I have this backend, and it looks like this, so our API at the Swift level should look like this. It's basically just an extension of your backend into Swift. And that might not be the best way to do it. So having just a bunch of them that are different, it forces us to look from the client. So these are images in sequence, which is kind of like video, a stream, perhaps. So our first iteration of this might be to have the client start a stream and have a delivery block with a frame, and you process the image and put it in the image view. Super easy, no problem. However, this processing is quite CPU intensive, and if we do it on the main thread, and you should be doing main thread by default in your API's opinion, this will make our UI all laggy and yucky. So perhaps we want our API to take a background queue in. So then we can choose, if we want it to deliver in the background or not. So here, fairly standard, you take a queue, we get the image on the background thread, we process it, we jump over to the main thread, and we put it into an image view. But image view, UI image view, is an image view, not a video view. And it turns out, if you put 40 new images in it every second, it still uses a lot of CPU. So what we need to do is, what happens is we get a backup, because image view is rendering slower than we're getting frames, and the frames are getting more and more in the past. Our memory usage is skyrocketing, super bad. So how might we do this? If we were shallow API, we didn't promise to do all this for the client. We were just like, well, you asked for frames, you've got frames, like you do it. And the client could implement a throttling thing and throw the frames away if they're not being dealt with fast enough. But everybody is going to do this if they're rendering, what the camera can see. So we should help them, really. So this is a very simple change. If you didn't notice it, we'll do that again. So all we do is we add a completion handler, which is thread safe. So when the client is done rendering, they can signal to the SDK that we're all good, and you can give me a new frame. And this will help throttle. It's a nice, simple way for throttling. So this is like a super simple change, right? But that tiny change is massive, because it changes this kind of streaming API into a push API, where it pushes frames to you, to a pull API, where you are pulling frames from it. So with a push API, API, the camera gives us frames, we parse them, we decode out the image, and we just push it to the client. Easy peasy. With that tiny completion handler, because it's a pull, well, now we need to check if the client is ready, and if it's not, we should buffer them so the client is never waiting, but we don't want to buffer too many because then it will still be in the past and we still use too much RAM. So we need to be smart about when we drop them, it's a whole other thing. So we've added this complexity because we've decided to have a very deep API boundary. So our decision to do everything for the client and be very helpful has cost us a lot more work. And in our case, this is worth it. In your case, perhaps not. Right. So this adventure has kind of taught us that, so looking at what the camera did, we would have implemented a push API. And we actually got there organically anyway. But because we kind of looked at it from the client's perspective, what they wanted to do, we actually decided that a pull API would be better. And we went through this decision organically by looking at what the client wanted, not what we were being given. And this has given a nice, friendly way for clients to use our SDK. So the second adventure is a little more esoteric. If anybody encounters this in their day-to-day lives, I have a secret whiskey cabinet in my office. It'll be fine. So one particular kind of camera is implemented as a state machine. So it goes into different states depending on what you're doing. And normally that's fine. State machines are quite a nice theory in computer science. I quite like them for certain tasks. The problem is the failure state for this particular same state machine is to freeze to the point where you need to pull the battery out of the camera to reboot it again. Now, this is bad. And I don't know if they have code that looks like this in it or what, but if you do anything out of order with a stupid thing, it will just freeze. So what we have is a very fragile service, and we do not want to expose that to the user of our API. And if it was just my app, it would be fine. I can learn how this works, make sure my app doesn't do it, and hopefully everything will be fine. But we have an API, and the API already exists, and it's designed not with a state machine in mind. So the client can call anything at any time, and the expected state is for it to just throw an error, which is a very sensible thing to do. No, you can't do this now, the camera's busy doing something else. Not, you can't do this now, and I need to tell the user to pull the battery out of their camera. So what do we do? So because we have this very deep API boundary, we can actually manipulate the camera behind the scenes. So, for instance, cameras can have more than one storage card in them, and you can stream using this API files off that. And you can, if you like, take 2 SD cards and stream files off them simultaneously. If you actually try and do that with this camera directly, it will just fall over and fail. So internally, the SDK is switching state to one card, streaming a bit, pausing that, switching over to the other state, streaming a bit of that, and it's kind of doing it in serial. It's a lot slower because the camera takes ages to switch around, but it does work, and we do not crash the camera, and the client is happy. And then we get bug reports saying it's slow, which is better than bug reports saying that we broke the camera. But in API design, especially if you're closed source, but even if you're not, because nobody really looks at the source code in an open source SDK, right? I mean, I've never done it. You can just lie. You don't need to really tell the truth. And if you have a fragile service, this can actually sometimes be a very useful tool. So with this particular camera, you always have to have live view running. Otherwise, just the camera won't do anything. But the API allows it to turn it on and off. So we lie. When you connect, we're receiving frames at 80 frames per second on this one. It's very quick. But we're like, no, we just dropped them all. And no live view. And then we get asked to turn it on. And we're like, yeah, we can do that. Yeah, it's difficult, but we just connect the two together, and off you go. And then when the client asks to turn it off again, we're like, yeah, it's definitely off now. And then we're just ignoring them again. And again, this is super rare. I didn't drink whiskey before I started this job. But if you are working with back-end services you don't control, and controlling hardware is getting more and more popular with the Internet of Things, Bluetooth devices and whatnot, and you will be maybe not surprised on how many pieces of hardware have a interesting way of operating. So tricks like this can really help. You may also choose to have a more shallow API boundary and expose this to the client and just let them deal with it, document it, it's fine. So this decision on where you place your boundary I wouldn't have had to do any of this work I've talked about if I decided, well, we'll just implement the connection part and then we'll just pass on, the implementation details of these things to the client and they can deal with it. But my product is very much, we deal with it so you don't have to. And if your product is more of a larger, back-endy kind of service, then perhaps you're fine with people having to learn it. So the whole point of this is you don't have to. And that decision can have huge ramifications on the amount of work you have to do and the kind of product you ship. So, to recap, I didn't actually talk about API design, I'm sorry. Today, we have learned that the API boundary is a very important thing. And when you are shipping code behind an API, it's important to know that you are shipping the requirement for the client to write a certain amount of code, as well as the code itself. You need to consider what might happen on this side, whether you want to be flexible in the future, whether you're okay with breaking the client side if you want to, because 10 years ago, we were all coding web stuff with XML, right? Now it's JSON, GraphQL is becoming more popular. Who knows what will happen in the next few years? But maybe you're fine with that. We have learned that cameras are stupid, just like every other piece of technology there is, really, as you saw with the projector earlier. And most importantly, we have learned that if the situation calls for it, even in programming engineering, it is okay, very occasionally, to lie. So, my name's Daniel Kennett. Thank you very much for listening to me today, and I hope you have a great conference. Thank you very much.